My receiver is tucked up in there, and in the front I have a 3300 milliamp hour pack, 3.3 amp hour. A lot of weight. Also, I have ballast weight in there because I haven't got my FPV transmitter and OSD set up in here, so I had to add a bunch of weight to balance this thing. In the very front, we have a GoPro Hero 2 mounted, and underneath we have a 3D printed skid plate that I made that allows us a place to anchor our battery and our GoPro to and spread the load out. Guys, these things are tough as nails. I can't get this thing on camera because it's just too big, but it is tough. For dollar store foam board, I am highly impressed. I can't wait to fly this. For push rods, really easy. Piano wire with a Z-bend. You've got your, I forget what these are called, the anchor point for the control horns. In between, I have a Tim Hortons coffee stir stick as a guide and 3D printed control horns. Really easy, nothing to it. If you have some basic electronics for RC, you can make one of these and get in the air in no time. Guys, that's about it. In the future, I'm going to show the maiden of this, I hope. Hopefully we don't crash right away. I'll get the OSD and the transmitter, the video transmitter hooked up, as well as probably another FPV camera in the nose so I don't have to fly through the GoPro. Guys, good luck in all your projects. Let me know what you think of this video in the comments. I'd really love to hear about it down below. If you're building something RC or into RC, let me know that too. Good luck, guys. Have a great week. Welcome back to the lab. Today I have a little bit of footage from my Phantom 3 Standard to share. I wanted to show you guys right out of the box what you can expect to get with the Phantom 3. The footage at the beginning is slightly edited. I added the bars at the top and bottom to simulate widescreen, as well as I added a 3-way color corrector, and that is all. The remaining footage is unedited straight out of the camera. I set it to the sunny conditions of the day manually at about 5500 Kelvin. Upcoming, I have a complete video of the tips and tricks I found on this quadcopter. I think they'll be of value because I didn't see them in other videos or posted online for the most part. This footage includes some of the worst conditions for any camera to cope with. It was high noon, so we have very little contrast, very flat, and it's spring. Everything is still dead, almost no color in the landscape. I think you guys will be impressed with the footage. Check it out, let me know what you think. See you next video. Hey guys, welcome back. Today we'll take a quick look at the assembly of the electronics and the code for the DIY gas sensor for emergency responders. So if you didn't already see the previous video, I'll link it down below. It shows you this assembly inside this ball that we can chuck into a dangerous area and remotely monitor our gas readings via the MQ2 sensor here. I've done a lot of testing on this. Sorry guys, this is a really ugly prototype because I already had this assembled for another use. I'll make a final version where we don't have this daughter board and we do a better job with the transmitter. The long and the short of it is we're using an Arduino Nano, a 433 megahertz amplitude shift keyed transmitter, a power supply, in this case I'm using the Adafruit Power Boost 500, and the MQ2 gas sensor. Quite simply, we're taking the measurements from the MQ2 and broadcasting them out via voice, so we can receive them with any handy-talkie like this. Works with any radio that's capable of receiving on the 433 area, 70 centimeter band. Works perfect. I'm really happy with it. This is a heated gas sensor, so this thing draws quite a little bit. It has a heated element in here, and we'll show you that. So here with an infrared camera, you can actually pick up the heat coming off this. Guys, I don't really recommend that you run this off the Arduino 5 volt, but for this prototype it worked just fine and I have yet to have a problem. There's the Arduino running happily, and transmitter no heat there, and the power boost minimal at best. But yeah, that's the long and the short of it. Let's have a look at this thing. So I'll throw a schematic overlay. You can find this on the Hackaday site as well, Hackaday.io. I'll post that down below. Guys, if you like this project, please consider going over to that link and give it a skull, which is basically a thumbs up like YouTube. Using that schematic, you can assemble yours no problem. Let's have a look and see what we get out of it via code. Let's go ahead and plug this into the serial port of the PC. See if we can get the serial monitor fired up here. That will reset the module. And we should get calibrating. We do. I'll let this calibrate and I'll cut back in a moment. Calibration is done. And we're back reading values. So I've printed this to serial in the codes for troubleshooting. It makes things so much easier. Let's turn off the external radio here. We'll go ahead and let's hit it with a little bit of gas. And there we go. We've got our readings. We picked it up on the LPG, no problem. Worked perfect. So let's have a quick look through the code here. I won't spend a lot of time on this. You'll be able to download this code and check it out yourself. I put lots of comments in. You'll see at the beginning, you have a link to the Hackaday site, to my channel, some information on what IDE to use. Make sure that you're using the same IDE as me if you run into errors. And some summary of the release notes from the different versions I've made. I've gone up, this is version 5 currently, there may be more. You need the talkie.h library, and here is the information from the original maker of this. Thank you very much to Peter Knight for making this available. We define what we need to say, so we need a bunch of numbers here. We need to be able to speak these numbers, and these are the values that the library is going to use. I added some more that I use, alert and smoke and calibrate and start, and there's a couple commented out. You can remove those if you really wanted to. This is where in the void say number, this is all the code related to converting the value and being able to get in voice. It's pretty self-explanatory once you get into it. Go ahead and read through at your leisure. The MQ2 code was ported in here as well, and here's the links to the original designers of this code, because I did not make it. Sandbox Electronics in 2011 put this together. Very cool. This is where we set up the curves for the smoke, CO, and liquefied petroleum gas, as well as the resistance value. In the start, you can see I just have it say start 3 times and calibrate to notify the user. This is where you're going to add, or I will add some code in the future to force a major delay to allow the sensor to warm up. Serial print calibrating, not much to it there. Calibration is done, kick out the values, and let the user know via the radio that we are ready. In the loop, there's not much to it. We're doing serial print the LPG value, say LPG, get the LPG value, and you'll see that down below how we do that on the curve, and go through, serial print it out. Not much to it, guys. Really, really straightforward. It looks more complicated than it is. We repeat that with the CO and the smoke. Nothing to it. In here is the original MQ2 code, where we actually do the resistance calculation. This is where we read the pin to get our actual values from the sensor and convert those over. And here you go. Here's where we return the values. Not much to it, guys. Really, really straightforward. Won't spend any more time on the code. That is all there is to it. So guys, as I mentioned, I'll go ahead and put this back together in a better package, get rid of this daughter board, put it back in the ball so we can go do some live tests. I've already done range tests on this transmitter. Works great so far, so I'd love to do some live tests in a building, in a smoke environment. This sensor is definitely not the best. We need to go to a commercial grade unit, but for now, for the proof of concept, hey, it's working fine, let's stick with it. Guys, make sure you go over and click the skull button on the Hackaday site. It really helps this project. Click the thumbs up down below if you like these videos. It really helps this channel. Good luck in all your ventures. I hope you build one of these. Thanks for watching. Hey guys, welcome back. Time for another mailbag video. Got a pile of parts in, most of which you can see I've gone through a lot of them, but I haven't been playing with many. I thought I'd give you a spin through before I really get into them. So let's just go ahead and get started with one here. Guys, what I got is a bunch of RGB LEDs. Pretty cool little devices. Let's go ahead and take one out. These are a really big dome top on them. They're not really fancy addressable units or anything, but I think these will do for some fun little projects. Basic, not much to it. 4 pins, nice big soft dome on it. We'll give them a try. Next up, let's see what we got. Ah, I remember ordering these. I've never seen anything like this, guys. These are actually little tiny air pumps. And let's see if I can get this on camera. I'm not sure. There we go. Mini pump. Voltage DC 3 volt. Wild little thing. I think this is going to be really handy for some projects. You just hook up some simple little like RC fuel line would be the right size, or aquarium air tank or aquarium air line, and we should be able to actually do some like soft robotics and have it inflate like muscles and tendons and stuff. It should be pretty neat little device. Big package next up. This one, I'll admit, I was playing with this already. I couldn't wait for this. This is the adapter cables that go with it, but here what we've got is a Pico Projector, 960 by 540. This is an LED projector that we're going to give it a try with a Raspberry Pi or the PC Arduino. I think this will be really handy. Oh, tight fit. Has an SD card for storage, so you can store some movies and stuff on it. It's about the size of a thick iPhone, and this will be a standalone video coming up, guys. I'm really impressed with the results of this. I had to play with it. We'll get looking at this in an upcoming video. As part of it, I got some adapter cables and some more cables so that we can hook this. It actually will hook up to my Android cell phone or any other HDMI type interface. We're good to go here with just about anything. It does work really good. We'll check it out upcoming. Next on the list, what do we got here, guys? Oh yeah. These are some USB stick designed, well, what I was hoping to use these for was the software-defined radios, and I got all excited about the price on these guys, and I think they have the wrong chipset. I don't think we can use these with our SDRs, but I will give them a try. We'll see what we can do. If nothing else, we got a remote and an antenna. The price on these, I forget, it was really cheap. It was cheaper than I'd ever seen them, which should have been a warning sign to me, but hey, oops. Next up here, We've got a 5.8 gigahertz 32 channel AV transmitter. This is going to be for the video downlink on the Versa wing. I simply love these transmitters. I believe they're, if I remember right, I think it's 600 milliwatt. Really good because it gets along with all the channels, all the standard FPV channels, so you can use your Fat Sharks or any cheap base station receiver, and they get along with everything. Comes with a simple antenna and a simple connection system. Really well done, actually. Great unit. We'll cover these in an upcoming video too. Next up, more RC stuff. This is a new module for my TH9X radio. What I wanted to do, let's see if I can get it out here. This is the FlySky that I'm using. All my receivers are just these cheap FlySky ones. What I wanted to do was mod this with a slightly better antenna system and capability of going to another amplifier, possibly, if you wanted to. It was easier than modding my existing one to just grab another to experiment with. And we'll give this a try in an upcoming video. More goodies, guys. This one I'll zoom in on. This is my new Rgb on-screen display. This is an OSD that gives you a heads-up display for your FPV planes. This just patches your telemetry into your video. With the GPS receiver here, it also comes with a programmer so we can customize it. BMS Web did an awesome video. I'll link down below to these the coverage of this unit. I grabbed it because it was ultra cheap. It can't do autopilot functionality, just display only, and displays your battery voltage and all the good stuff. Really cool unit. This is going on the FT Versa wing. Next up, more RC related items. We've got some Lipos. I grabbed these. These aren't only going to be RC related. I use the 2-cell Lipos a lot in my Arduino projects, and these are significantly smaller than my existing ones, only 250 milliamp hour, 20C rated. I don't know whether I'd really try and pull 20C from these, but hey, you guess you could. Really handy little package for feeding your Arduino projects for a long time. With the nanos I use, the raw input pin, they can handle the 2-cell Lipo no problem and use the onboard regulator, and you're set. Great little batteries. Can't wait to charge these up and give them a go. Last up, guys, we've got a box here, and I've already been into this. I just had to. This came from Great Hobbies here in Ontario. I had to get one of these. I am committing to bringing you guys some better RC footage this year, and this is going to help me do it. I have my razor blade handy. We have a Mobius camera. This is with the C lens. We've got a wide angle lens on it. Looks like I tapped the power button by accident. Really nice wide angle lens. Should work great. Full HD for onboard video. Really looking forward to using this. It comes with your standard USB cable, nothing special. A mount, which I can 3D print just about any kind of mount I want. Tripod mount as well. And separately, I did order this. This allows you to do live video out and feed the battery within the Mobius from onboard the plane. If you chose to fly through this, you could. I likely never will. This will be more for external views, but what I can do is I can add this to my EPP FPV and put it into my camera switcher and use this as an external view, and I can view it through my heads up. So yeah, we'll give this a try, guys. Really looking forward to bringing you some good videos this year. If you like this sort of thing, please consider a thumbs up below. It really helps out the channel. I can't wait to show you some onboard FPV footage this summer. Cheers, guys. If you're like me and work with many electronics parts in your projects, this handy little component tester might be just right for you. I found this little tester on icystation.com and decided to give it a try. It brags it can test a variety of components and feedback the values and information on them via the LCD display.
The tester came pre-assembled on a quality PCB and only lacks a case, which I can easily remedy with my 3D printer. I was slightly surprised to find that the main microcontroller on board is actually an Atmel Mega 328P 8-bit AVR. This is the same microcontroller used on many Arduino boards. A quick search online and I was able to find the schematic for the board as well as the code. This is actually a great feature, as now if we find any